the integral of sine squared 3x dx. Now the textbook suggests replacing sine squared with half 1 minus cos 2. Where did that come from? Well, on the formula sheet, it's from here, the double angle identities. Sine squared is half of, well, that's negative sine squared, so that's got to swap to the other side. Sine squared is half of 1 minus cos twice the angle. So let's try it here. That is the integral of half of 1 minus cos twice the angle. And this we can do. So put the half outside. It's half of the integral of 1 minus cos 6x dx. And that is half of, well, what's the integral of 1? That's x. And what's the integral of cos? It's going to be sine. And because there's a 6 in here, I want 1/6 of that. Sorry, not dx anymore. Let me fix that, sorry. Confused what step I was up to. Plus constant. I probably would go one more step and write that as half x minus 1/12 sine 6x plus constant. Let's try another one. The integral of 5 plus 3 tan squared 2x dx. Well, integrating tan squared is difficult, but integrating sec squared is possible. The textbook says to replace tan squared with sec squared minus 1. Where did that come from? Again, from up here, 1 plus tan squared is sec squared. So tan squared is sec squared minus 1. So this is the integral of 5 plus 3, and this was sec squared 2x minus 1 dx. Next, expand these brackets. I'm going to get, I won't skip a step, I'll do it all carefully. 3 sec squared 2x minus 3. So now 5 take 3 is going to be 2 plus 3 sec squared 2x. Now, what's the integral of sec squared? Well, on your formula sheet, you actually have an integral of sec squared is actually tan. This then becomes, the integral of 2 is 2x. This is 3 tan 2x divided by that 2 plus constant. Sometimes the substitution won't be immediately obvious. Let's try the integral of sine cubed x dx. Well, I don't have a rule for sine cubed, but I do for sine squared and for cos squared. Let me replace this with sine x times sine squared x. Then replace this 1 with 1 minus cos squared x. Why did I do that? Well, if I substitute in here, the derivative of cos x is sine x. So I think this is going to work well. So, let u equal cos x. Then du dx equals negative sine x. Okay, this is the integral of sine x is actually this. It's a negative. This bit is 1 minus u squared. I want du dx over here times negative sine x dx. But I added a negative sign, so I'm going to add a negative sign out the front. So that's negative the integral of 1 minus u squared times du dx dx, which is negative the integral of 1 minus u squared du. Now this is an easy integral. Negative of 1 becomes, sorry, we're doing with u, aren't we? U minus u squared becomes u cubed on 3 plus a constant. But u, remember, was cos x. So this is negative cos x plus cos cubed x on 3 plus constant.